first thing you want to do when you get a scatter plot, you're going to have an x and y value. Normally your x value is going to be either the very first column, or if it's in a row, it's going to be the very top row. So your x is going to go first. It's either the one on top or the one to the left. So it's the very, very first one. We click on Stat. One edit will be give us to our tables. I already inputted some numbers here. So notice here line 1 is going to be my x. Line 2 is going to be my y. Here I have 15 values. Next, instead of doing your regular like y equals, right, you could now graph this, and you could go it and then try to look for it, and yeah, here it is. Yeah, you could graph it, but it's not that helpful. What I recommend actually doing is going to Stat and then go to Calculate and then pressing number 3 for regression. That one is going to give you a better sense of the scatter plot. Notice here it gives you the scatter plot in all of its forms. It puts a line through it. It gives you all the dots. It tries to create a good line, and then it gives you instantly your R value. Your R value equaling negative 0.8668. So that is your R value. From that, I can already tell with a negative 0.8, it is a strong correlation.
But what does that mean to have a strong correlation? And what does that mean to have a strong negative correlation? Well, it really goes into our factor of what was our x and what was our y. Our x value in this case was the amount of horsepower, and our y value was the fuel mileage, miles per gallons, that I got on the highway. So I notice here so you can say as my gas horsepower was increasing, right? The more I revved up the engine, my fuel mileage or mileage efficiency was decreasing. So there was a strong correlation between one causing the other. It's a negative correlation because as one increased, the other one decreased. And let's talk a little bit more about some other concepts here. Let's talk about normal distributions or any distributions. So with scatter plots and the normal distribution and z-score. Okay, so if something has a normal distribution, so let's say I wanted let's say here is a city. I'm going to draw this a city. This is like the boundaries of a city. And I wanted to get the fuel of the distribution of, let's say, transit riders, right? Well, I notice here as the amount of transit riders, the closer into the center of the city as I get, there are more public transit riders, right? I'm just going to call this transit. However, as I got further out to the city, there is less, right? And even less. And so this would be a good representation of a normal distribution. Let's say the problem asked you, it's like, oh, I wanted to expand. Originally, I'm going to draw this in green. Originally, my data covered this amount of area, and it had a nice normal distribution based on that. However, let's say I wanted to increase my area, and for the case of this particular example, there aren't any other cities within the next, say, 50 miles. And I wanted to expand it even further, right? Around out here. Well, since we have a normal distribution, and even though we expanded our range, right, our reach who who we're going to take, that doesn't change our correlation. It doesn't change our data set whatsoever because of the normal data set. So with a normal data set, unless something crazy happens, like I'm including another city or whatever, it's not going to change my data. So normal data sets will stay the same. Okay, so normal or z-scores. However, let's try something different. Right now, let's say I have an outlier. Outliers will change my you have to be very careful in terms of outliers. In some cases, some outliers can change what your what your R score is, and it could drastically make it look different. So outliers are something that you have to be careful of, right? And understanding that there are potential outliers. So outliers is where this is where, you know, the box and whisker plot, the outliers don't really impact them so much. With a scatter plot, an outlier could impact a scatter plot. Let's say here with our normal distribution. This is our normal distribution, and things are looking good. Everything's kind of linear, right, with our normal distribution. However, when we reached this, expanded this range, and we had an outlier. We had a crazy outlier. Let's say out here. I'm going to draw this even a bigger red, because we reached and we ran into a commune out in the middle of nowhere, but they use public transportation because they don't believe in harming the environment. So more public transportation, the better. But they like to live out away from urban areas. So this commune here, being our outlier, will drastically change our scatter plot and data set, and it might drastically reduce our regression to closer to zero, where there doesn't seem like there's a lot where there is any correlation to where someone lives in terms of their uses of public transportation, even though that's not true. So those are something that we always have to be cognizant of when we are thinking in terms of our data.